So spherical coordinates. Using spherical coordinates, evaluate the triple integral. So spherical coordinates, the conditions are x is equal to rho sin phi cos theta, y equal to rho sin phi sin theta, and z is equal to rho cos phi. So this is similar to the cylindrical coordinates. What is cylindrical coordinates? Here we use z is equal to z only, and here r sin theta and r cos theta. So spherical coordinates are used to evaluate triple integrals. If the question contains the equation x square plus y square plus z square, then we can use these spherical coordinates to evaluate that integral. So in our question, this is one example. This question also contains the equation x square plus y square plus z square. So we can use the spherical coordinates. The first one, x is equal to rho sin phi cos theta and y is equal to rho sin phi sin theta, z is equal to rho cos phi. Therefore, this x, y, z satisfies the equation x square plus y square plus z square is equal to rho square. And dv, what is dv? It is dx, dy, dz, or dy, dx, dz, or dz, dy, dx. That value is equal to rho square sin phi d rho d phi d theta. So don't change this order. And this theta varies from 0 to 2 pi. That means this is full circle. And phi satisfies the condition, or phi varies from 0 to pi only. That is upper half only. And rho, it is 0 to 1, because here the question is in x square plus y square is equal to 1. So therefore rho varies from 0 to 1 only. So if it is here 4, we use 0 to 2. Now we can substitute all these values in the given equation. What is the equation? That is e power x square plus y square plus z square whole power 3 by 2 dv. So what is x square plus y square? That is equal to rho square power 3 by 2. Then dx, dy, dz becomes rho square sin phi d rho d phi d theta. And the theta varies from 0 to 2 pi and 0 to pi, 0 to 1. So now these are independent functions. What is independent function? This limit is fully constant. The second limit is fully constant. Third limit is also constant. And we can separate all these parameters separate. That is rho terms we can separate. Sin phi terms we can separate. Also this theta terms we can separate. So that means this function is fully independent. So we can directly find the integration. So that is, first you integrate with respect to rho. Here the power is rho cube. So e raised to x integration is e raised to x only. It is valid only if x derivative in the denominator, or it is a multiple of its x derivative. So here rho cube. So we can use the e power formula here only when if it has the derivative term. What is the derivative of rho cube? The derivative of rho cube is equal to 3 rho square. But in our question this contains what? That is, this term contains only rho square. So we multiply and divide by 3. Then what is the answer? E raised to rho cube. So if this is x, that is rho cube is x, then this is dx. 3 rho square d rho is dx. That means e raised to x dx. So if here no dx, we cannot apply the formula. So that is why we arrange this 3. So e power rho cube into 3 rho square d rho. Now this is fully e raised to x. What is integration of e raised to x? E raised to x is e raised to x only. So e power rho cube, the limit is 0 to 1. Now we can apply the limit, that is e raised to 1. minus e raised to 0, that is for rho. Now we integrate with respect to theta and phi simultaneously. So that is theta varies from 0 to 2 pi. So we can take theta times. What is the theta times? Only d theta. So only d theta we can write here. Now phi varies from 0 to pi. Therefore, what is the phi times sin phi d phi? So the internal integral becomes 0 to pi sin phi d phi. The external one is 0 to 2 pi to d theta. Now d theta integration is theta. Sin phi integration is minus cos phi. Now we can separate apply the limit for each terms. That is 2 pi minus 0, that is 2 pi only. Here minus into cos phi minus cos 0. What is cos phi? Cos phi is equal to minus 1. Cos 0 is equal to 1. So minus 1 minus 2 into minus that means plus 2. So our answer is 4 pi by 3 into e minus 1. So this is our required answer.